Today we're going to talk about section 4.3 in our Algebra 2 BJU Press textbook. So the 4.3 is all about the quadratic formula and how we can use the quadratic formula to solve for x in a quadratic equation. So 4.1, we learned how to solve a quadratic equation by factoring. And in 4.2, we learned how to solve for a quadratic equation by completing the square. And in 4.3, we're going to learn a third way to solve a quadratic equation to solve for x using the quadratic formula. But first, we need to know, where did the quadratic formula come from? How does it work? So we're going to talk about the proof of the quadratic formula first. So we're going to start with the general form of a quadratic equation, which is ax squared plus bx plus c equals 0. And remember that the a and the b and the c all represent real numbers. So those are going to be useful for whenever we have to use the formula to solve for x. So we are wanting to solve for x. So what I'm going to do is I'm actually going to complete the square on the general form of the quadratic equation. And when I complete the square, I'll be able to solve for x. So remember the steps to complete the square. First thing you do is you remove the constant from the left-hand side. So I'm going to remove the constant by subtracting c from both sides. And then I have ax squared plus bx equals negative c. All right, the next thing in completing the square is to factor out the a on the left-hand side. So remember, when you factor out the a, it's almost like you're dividing by a from every term. So ax squared divided by a becomes x squared. And bx divided by a becomes b over ax. And that's equal to negative c. Okay. So now that I've done that, I can complete the square. So remember, you take the value in front of x, which is b divided by a. I'm going to take half of that, and square it. So that becomes b over 2a squared, which becomes b squared over 4a squared. So that's what I want to add to both sides. So I'm going to add b squared over 4a squared to both sides. So now I have a times x squared plus b over x plus b squared over 4a squared equals negative c. And I want to add this b squared over 4a squared. But remember, I'm not just adding b squared over 4a squared. I'm adding a times b squared over 4a squared. So I'm adding a times b squared over 4a squared. All right, so let's go ahead. I'm going to simplify that and we'll move on. So when I simplify, I have a times x squared plus b over ax plus b squared over 4a squared equals negative c plus, so this a is going to cancel one of these a's, leaving me b squared over 4a. All right, so we almost look like a mess right now, but it's okay. We're going to be all right. So the next thing that we want to do, it's going to get better, I promise. We're in the middle of the proof right now, but we're going to keep going and it's going to clear up, I promise. So now that we have taken half of our b value, or the term in front of the x, we took half of it and squared it, and we added that to both sides. Now the next thing to complete the square is to rewrite this perfect square trinomial as a perfect square. So that's going to become x, because the square root of x squared is x, plus the square root of b squared over 4a squared becomes b over 2a. All right, and so I still have all of this on this side. So now what I would like to do is I need to divide everything by a. So because I'm trying to solve for x, right? So I need to take care of this a. So I want to divide everything by a, but another way to say divide everything by a is multiply everything by 1 over a. Because if I multiply by 1 over a, it's the same as dividing by a. So I'm going to multiply c by 1 over a, and I'm going to multiply b squared divided by 4a by 1 over a. So now I have x plus b over 2a squared equals negative c times 1 over a becomes negative c over a, plus this becomes b squared over 4a squared. All right, so before we square root both sides, I want to go ahead and simplify this a little bit more because I've got two fractions going on. So what I'm going to do is, in order to add these two fractions, I have to have a common denominator. So to have a common denominator, I need to multiply this first fraction by 4a. So then I get negative 4ac over 4a squared plus b squared over 4a squared. Okay, so now what I can do is write that as one fraction. Okay, so I have x plus b over 2a squared still on the left hand side, and this becomes negative 4ac plus b squared, which I'm just going to rearrange that and put b squared minus 4ac, so that way the positive and then the minus, right? And that's all over 4a squared. So last step is to, well, almost last step, square root both sides. Okay, so I'm going to go ahead and start a new page and do that. So again, I'm square rooting both sides. So don't forget that when you square root both sides, you get the plus and the minus, right? Or plus and minus. So we now have x plus b over 2a equals plus or minus the square root b squared minus 4ac over 4a squared. So that square root on the right hand side, that can be divided up into the numerator and the denominator. So what I'll have then is I'll have plus or minus the square root of b squared minus 4ac over the square root of 4a squared. And then the square root of 4a squared is 2a. So now I have this. So my last step is to subtract b over 2a from both sides. So now I have x is equal to negative b over 2a. And then remember I have plus or minus the square root, plus or minus the square root b squared minus 4ac over 2a. Since the denominators are the same, I can go ahead and write this over one fraction. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is the quadratic formula, which you're going to have memorized. So that was the proof. You need to be able to replicate the proof and be able to do it yourself. So you should be able to take the quadratic formula and complete the square and solve for x. And when you do, you get the quadratic formula, which again is x is equal to negative b plus or minus the square root b squared minus 4ac all over 2a. So there are several ways you can memorize it. There's actually a song. It goes to the tune of Pop Goes the Weasel. So if you YouTube that, look for quadratic equation or quadratic formula to Pop Goes the Weasel, the song will come up. And I think there's even one where there's a little girl, she's like 5 and she's singing it. So it's very catchy. It's very easy to learn. So whatever it is that's going to help you memorize it, get it memorized because you need to know it. You need to know it. So let's go ahead and try some problems using the quadratic formula. So I'm going to start with example 1. And example 1 says solve 4x squared plus 3x minus 9 equals 0. And so I want to use my quadratic formula. To use the quadratic formula, I have to know what a is, what b is, and what c is, so that way I can solve for x. So I know that a is 4, b is 3, and c is negative 9. Okay, because the a comes before the x squared, the b comes before the x, and the c is your constant term. So now I have x is equal to negative b, and b is 3, so negative 3, plus or minus the square root, b squared, so 3 squared, minus 4, times a, which is 4, times c, which is negative 9, all over 2 times a, which is 4. So now I just evaluate that. So I get negative 3 plus or minus. This becomes 9 minus 4 times 4 is 16. And then I'll do 16 times 9. And I get 144. So 9 minus negative 144. So that becomes plus 144 because I was minus a negative. And then all over 8. So 9 plus 144 is 153 over 8. Okay, so I have two answers because I have plus and I have minus. So my two answers, first of all, I can't take the square root of 153. I'm just going to leave it there. I can simplify it a little bit, but I haven't shown you how to do that, so don't worry about that. I can't take the square root of 153 though. It's not a perfect square. So from here, I'm just going to write my two answers. Either x is equal to negative 3 plus the square root of 153 over 8, or x is equal to negative 3 minus the square root of 153 divided by 8. So those are my two answers. Let's try another example. We're going to do example 2. Which says solve x squared minus 3x minus 28 equals 0. So my a doesn't look like it's there, but it's actually 1. My b is negative 3, and my c is negative 28. So when I fill this into the quadratic formula, which is x is equal to negative b plus or minus square root, b squared minus 4ac all over 2a. So x is equal to negative b. So negative and then b is negative 3 plus or minus the square root of b squared. So b is -3. So -3 in parentheses squared minus 4 times a, which is 1, times c, which is -28. All over 2 times a, which is 1. All right, so time for some math. -3 becomes 3, plus or minus. -3 squared becomes +9, as long as you do your parentheses right. -4 times 1 times -28 is going to become +112 over 2. So 3 plus or minus 9 plus 12 is 121. And it's all over 2. And then the square root of 121 is actually 11. So since I can take the square root of 121, I'm going to go ahead and do that. So now I get x is equal to 3 plus or minus 11 over 2. So again, I get two problems. Either x is equal to 3 plus 11 over 2, or x is equal to 3 minus 11 over 2. So remember, I get two problems. So 3 plus 11 is 14, and then 14 divided by 2 is 7. So that's one solution. And then 3 minus 11 gives us -8, and then -8 divided by 2 is -4. So that becomes my other solution. So I get 7 and I get -4. And you could have said, Miss Moss, well, I could have done that easily. I could have factored this original equation. I know that the two factors of x squared minus 3x minus 28 is going to become 7 and 4, because those multiply together to get -28, but add up to -3, which means that x is equal to 7 and x is equal to -4. So you're like, well, why didn't I just do that? Why did I do all of this work and get those two answers? Well, this is an example where you have a quadratic equation that factored nicely into -7 and 4. But sometimes your quadratic equations are not going to factor nicely. You might be using that box method and you can't get anything that works. And if that's the case, then break out the quadratic formula, and the quadratic formula will give you the answers for sure, okay? So just remember that if you use the quadratic formula, just like if you're going to solve by factoring, both of those you have to be set equal to 0 in order for them to work. So if you have anything on the right-hand side, you have to move those terms over to the left-hand side before you can use your quadratic formula or use factoring like we did in 4.1. So go ahead and try some problems on your own.